Every single day, billions of people pour sugar into coffee, desserts, candy, soft drinks, and thousands of other foods without ever thinking about where it actually comes from. But behind those tiny white crystals hides an enormous industrial system so massive that some factories process mountains of sugarcane almost non-stop, surrounded by roaring turbines, crushing steel rollers, boiling tanks, and machines powerful enough to tear through entire fields in hours. What looks like a simple tropical plant is actually the center of one of the largest food production systems on Earth. And the craziest part is this process starts racing against time the second the sugarcane is cut, because once harvested, the sugar inside the plant immediately begins breaking down. Every delay reduces quality. Every lost hour affects production. That pressure forces farms, truck fleets, and giant factories to operate with astonishing coordination from the very first cut in the field. Out in the plantations, harvesters the size of buses move through endless rows of sugarcane at high speed, slicing thick stalks near ground level, while transport trucks drive beside them in perfect synchronization. Within minutes, freshly cut cane begins moving toward gigantic industrial facilities where the real transformation begins. Inside these factories, the environment feels more like a giant power station than a food plant. Conveyor systems carry rivers of chopped cane through massive crushing lines built from giant steel rollers, capable of squeezing out nearly every drop of juice hidden inside the fibers. Boilers thunder under extreme heat. Turbines generate electricity continuously. Entire buildings vibrate as thousands of tons of sugarcane move through the machinery every day. And even the leftover fiber still has a purpose. What remains after extraction will soon fuel giant furnaces powerful enough to help run the factory itself. So this is not just a story about sugar. It's a story about industrial efficiency, giant machines, heat, pressure, chemistry, logistics, and one of the most optimized agricultural systems in the world. Because transforming sugarcane into refined sugar is far more complicated than most people imagine. The process begins thousands of kilometers away from supermarkets, inside enormous tropical plantations, stretching so far that from above, they look like green oceans covering the landscape in countries like Brazil, India, and Thailand. Sugarcane fields can extend beyond the horizon, feeding gigantic factories that depend on fresh cane deliveries every hour of the day. But these fields are not simply planted and forgotten. Modern sugarcane farming has become a highly coordinated operation driven by timing, precision, and industrial-scale planning. Farmers monitor soil conditions, irrigation levels, plant health, weather patterns, and harvesting schedules carefully because harvesting too early reduces sugar concentration, while harvesting too late can damage the crop and lower factory efficiency. Everything has to happen at exactly the right moment. Months before harvest season begins, preparation is already underway. Machines inspect the fields, irrigation systems stabilize moisture levels under intense tropical heat. Agricultural teams track crop development using satellite imagery and smart sensors, capable of identifying weak areas before problems spread across entire plantations. And unlike many crops, sugarcane is not grown from seeds. Instead, farmers cut sections of mature cane stalks and place them directly into the soil. These stalks contain hidden growth nodes that quickly develop into entirely new plants. Within weeks, huge fields begin transforming into dense rows of fast-growing cane, absorbing sunlight, water, and nutrients almost continuously. Over time, the stalks become thicker, taller, and heavier as sugar slowly accumulates inside the plant. Eventually, the fields reach the moment everything has been preparing for: harvest season. This is where the calm agricultural landscape suddenly transforms into a high-speed industrial operation. Before sunrise, giant harvesters begin rolling into the fields. Powerful engines roar to life. Rotating cutting systems spin at incredible speed, while massive wheels crush through muddy terrain. Operators guide the machines through tightly packed rows with astonishing accuracy. These machines do far more than simply cut plants. As they advance forward, spinning blades slice the sugarcane near ground level while secondary systems remove leaves and unwanted material in the same movement. Inside the harvester, The cane is chopped into smaller sections almost instantly before passing through powerful cleaning systems that separate useful material from loose debris. And all of this happens while the machines continue moving through the field without stopping. Beside them, transport trucks drive in near-perfect synchronization, collecting chopped cane while both vehicles remain in motion. The coordination must stay incredibly precise because even short interruptions can slow down the factory systems waiting ahead. And this is only the beginning, because once the trucks are full, the real race begins. The moment sugarcane is harvested, an invisible countdown begins. Inside every freshly cut stalk is sugar that starts degrading almost immediately under heat and natural bacterial activity. Factories cannot afford delays. If the cane remains too long in the field, sugar recovery drops, quality decreases, and entire shipments lose value within hours. That is why modern sugar production depends on one thing above all else: speed. Across enormous plantations, loaded transport trucks begin leaving the fields one after another in an almost continuous flow. Some roads become moving rivers of sugarcane stretching for kilometers as drivers rush toward giant processing facilities operating day and night during harvest season. In the world's largest sugar-producing regions, the operation barely slows down. While one harvesting crew works under the burning afternoon sun, another continues through the night beneath massive floodlights. Tire fleets rotate in shifts because the factories ahead are designed to consume unbelievable amounts of sugarcane every single hour. If delivery slowed down, production efficiency immediately suffers. Some industrial plants process thousands of tons of cane every day. And every section inside the facility depends on a steady supply arriving from the fields with near-perfect timing. The crushing mills, the boilers, the turbines, the purification systems. Everything downstream depends on fresh cane reaching the factory fast enough. And the logistics behind that movement are enormous. In some regions, specialized train systems transport huge quantities of sugarcane from distant plantations directly into industrial zones. Long cargo lines packed with chopped cane move continuously toward giant processing plants surrounded by steam towers, storage facilities, and conveyor systems large enough to resemble industrial cities from the air. As the trucks approach the factory grounds, the operation becomes even more organized. Vehicles line up at digital weighing stations where every load is recorded before entering the unloading zone. Industrial control rooms track harvesting rates, transportation schedules, incoming deliveries, and processing capacity in real time across the entire network. Nothing here runs on guesswork. A late shipment can affect the rhythm of the entire plant. Once weighed, samples from every delivery are sent for rapid testing inside laboratory stations near the reception area. Technicians analyze sugar concentration, moisture levels, and impurities using automated systems capable of evaluating the quality of incoming cane within minutes. This stage determines how efficiently the factory will be able to extract sugar from each load. It can also determine how much farmers are paid. Higher sugar concentration means higher value. Outside the testing stations, truck lines continue arriving non-stop, while unloading platforms operate at incredible speed. Hydraulic systems lift entire truck beds into the air as tons of chopped sugarcane crash downward into giant steel hoppers below. The sound inside these reception areas is overwhelming. Engines roar across the loading bays. Metal walls shake under impact. Conveyors rumble beneath the floor. Steam escapes from distant processing lines deeper inside the plant. And beneath all that noise, giant transport systems begin pulling the sugarcane toward the center of the factory. At this point, the agricultural phase is over. Now the plant enters a fully industrial environment. Massive conveyor belts carry endless streams of chopped cane through enclosed processing corridors while operators monitor machinery from elevated platforms surrounded by vibration, dust, and heat. Some belts move so much material that they resemble flowing rivers disappearing into the depths of the facility. But before the sugar can be extracted, the cane must pass through another critical stage: cleaning. Even after mechanical harvesting removes much of the debris in the field, incoming cane still carries dirt, sand, rocks, roots, insects, and loose plant material capable of damaging expensive industrial equipment further down the line. and the crushing systems ahead are far too powerful and expensive to risk contamination. So the cane moves into aggressive cleaning systems where high-pressure water jets blast away mud and debris, while rotating separators and vibration systems remove unwanted particles before processing begins. Inside some factories, giant rotating drums tumble the cane continuously, while sprays wash the material from multiple directions at once. Other plants combine airflow systems with mechanical agitation to separate lighter waste before the cane advances deeper into the facility. The volume moving through these systems is enormous, and modern factories cannot afford to waste huge amounts of water during peak production. So many plants recycle large portions of the cleaning water through industrial filtration systems that remove sediment and contaminants before sending the water back into circulation again. This helps reduce environmental impact while supporting non-stop factory operations during the busiest parts of harvest season. Once cleaned, the sugarcane moves forward through enclosed conveyor networks toward the loudest and most violent section of the entire operation, the crushing line. This is where giant steel machines will begin tearing the plant apart to recover every possible drop of sugar-rich juice trapped inside the fibers. And from this point forward, the process becomes far more intense. Deep inside the factory, the atmosphere changes completely. The air becomes hotter, the noise becomes heavier, and the machinery suddenly feels enormous. This is the crushing zone, one of the most violent and powerful stages in the entire sugar production process. Here, thousands of tons of sugarcane are ripped apart, compressed, soaked, crushed again, and forced through giant industrial systems designed to recover nearly every drop of sugar hidden inside the plant fibers. And the scale is difficult to understand until you stand beside the machines. Some crushing mills rise several stories high. Massive steel rollers rotate continuously with enough force to flatten dense cane fibers that only hours earlier were growing under tropical sunlight. Entire sections of the building vibrate from the pressure generated inside the equipment. The process begins with preparation cutters. As conveyor belts feed cane deeper into the facility, giant rotating blades spinning at extreme speed begin shredding the stalks into much smaller fragments. The goal is simple: destroy the structure of the plant before extraction begins. The smaller the fibers become, the easier it is to recover the sugar trapped inside. From above, the shredded cane looks almost like an endless river of yellow-green material moving rapidly through tunnels filled with steel machinery, conveyor systems, and overhead steam pipes. Workers nearby wear heavy hearing protection because the sound inside this area can become deafening during peak production. Then the material reaches the rollers. This is where brute force takes over. The chopped cane passes through a series of giant crushing mills aligned one after another. Each set contains enormous metal rollers spinning in opposite directions, while applying tremendous pressure to the plant material squeezed between them. The first mills begin tearing the fibers apart. The next mills compress them even harder. Then the pressure increases again and again. At every stage, more juice bursts out from the shredded cane. Flowing beneath the machines is dark greenish liquid loaded with dissolved sugar. But even after several crushing stages, valuable sucrose still remains trapped deep inside the fibers. So operators inject hot water between the roller systems in order to wash out the remaining sugar before the material leaves the extraction line. This process dramatically improves recovery rates and allows factories to extract far more sugar from every ton of harvested cane. Meanwhile, the machinery never slows. Conveyors continue feeding material forward. Rollers keep turning under immense pressure. Heavy motors shake the floor beneath the operators. Steam drifts through the upper sections of the plant. And during peak season, shutting down these systems becomes extremely expensive and technically difficult. Some factories operate for months with only minimal interruptions, while maintenance crews work continuously. Behind the scenes, to prevent failures before they spread across the production line, conditions inside the crushing area can become brutal. The temperature rises near the steam systems. Fine cane particles float through the air. Floors tremble under the weight of industrial equipment powerful enough to process massive volumes of plant material every hour. Yet despite all this force and destruction, something remarkable begins happening. The factory starts creating its own energy. After repeated crushing cycles, the remaining sugarcane fibers eventually emerge dry and almost completely drained of juice. This material is called bogus. To most people, it would look like useless waste. But inside modern sugar factories, bagasse becomes one of the most valuable resources in the entire operation. Instead of discarding it, giant conveyor systems transport the dry fibers directly toward industrial boiler units elsewhere inside the facility. There, the bagasse is burned under extreme heat to generate enormous amounts of steam. And that steam powers the factory itself. High-pressure vapor rushes through massive pipelines toward industrial turbines, capable of generating electricity for crushing systems, pumps, conveyors, purification equipment, and other sections across the plant. Some sugar factories become nearly energy self-sufficient during harvest season. Others produce excess electricity that can be transferred into regional power grids, effectively turning the plant into a temporary power station while production is running at full capacity. The visuals inside these energy sections feel completely different from the agricultural world where the process started. Furnaces glow deep orange behind heavy steel walls. Massive pipes carry superheated steam through the building overhead. Turbines spin behind protective barriers while operators monitor pressure systems from enclosed control rooms filled with flashing screens and live production data. Everywhere, the factory is consuming, crushing, burning, boiling, and transforming materials simultaneously. And beneath the crushing mills, the extracted liquid finally begins moving toward the next critical phase of the process. At first glance, the juice looks nothing like sugar. It is dark, foamy, unstable, filled with microscopic fibers, dissolved minerals, soil particles, and organic residue pulled directly from the cane during extraction. But hidden inside this murky liquid is the ingredient the entire factory has been racing to recover from the very beginning. Sucrose, and transforming this unstable raw juice into clean white sugar will require an entirely different kind of industrial process. Because the next stage is no longer about force. It is about chemistry, heat, and control. The raw sugarcane juice leaving the crushing mills looks nothing like the clean white sugar people see in stores. It is thick, dark greenish-brown, filled with foam, microscopic plant fibers, dissolved minerals, organic compounds, and tiny particles pulled directly from the cane during extraction. If this liquid moved straight into crystallization, the final product would have poor color, strange flavor, and inconsistent quality. So before sugar crystals can form, the factory has to completely transform the juice. And this stage becomes far more controlled and precise than the violent crushing systems earlier in the process. As the raw liquid enters giant purification tanks, operators begin adjusting one of the most important variables inside the entire factory. Acidity. Sugarcane juice naturally contains unstable compounds that can damage sugar quality during heating. To stabilize the liquid, carefully measured amounts of lime solution are added into enormous mixing tanks, where industrial agitators keep the juice moving continuously. Almost immediately, chemical reactions begin inside the liquid. Tiny impurities start binding together. Undesirable compounds become heavier. Microscopic particles combine into larger masses that can be removed more easily later in the process. The juice flows through heating systems where steam rapidly transfers heat into massive pipes and processing vessels. Pumps force huge volumes of liquid through purification circuits while operators monitor chemical balance, temperature, and flow conditions from elevated control stations overlooking the factory floor. Inside giant clarification tanks, gravity slowly takes over. Heavy impurities sink toward the bottom, forming thick, muddy layers while cleaner juice separates above. The process looks surprisingly calm compared to the crushing mills earlier, but the scale remains enormous. Some facilities circulate rivers of juice through purification systems large enough to fill entire industrial buildings with pipes, valves, pressure controls, and steam networks stretching in every direction. The atmosphere inside these sections feels dense and humid. Metal surfaces drip with condensation. Warm vapor hangs in the air. Industrial pumps hum beneath the floor, while thick liquid continues moving through the system hour after hour. Even the waste removed during clarification still serves another purpose. The muddy residue contains minerals and organic material valuable for agriculture. So many factories later send it back into sugarcane fields as fertilizer, helping support future harvests while reducing industrial waste. But even after purification, one major problem remains. There is still far too much water inside the juice. And until most of that water disappears, crystallization cannot begin. So the liquid now enters one of the hottest and most energy-intensive sections of the entire operation: evaporation. This area feels less like a food factory and more like the engine room of a giant industrial ship. Massive evaporators tower above the floor, while giant steam pipes thunder overhead, carrying heat across different sections of the plant. Inside these huge vessels, the clarified juice is heated repeatedly under carefully controlled pressure conditions designed to remove water without damaging the sugar itself, because overheating the liquid too early can ruin the entire batch. If temperatures rise too aggressively, the sugar begins caramelizing before crystallization even starts, affecting color, texture, and quality. So factories use multi-stage evaporation systems where pressure gradually drops from one chamber to the next. This allows water to boil at lower temperatures, and it dramatically improves energy efficiency. Instead of wasting heat, the factory keeps recycling steam from one chamber into the next, extracting more energy from every stage of the process. Giant valves open and close automatically while operators monitor pressure levels. Through digital control systems connected across the entire evaporation network. Meanwhile, the juice itself begins changing rapidly. As more water disappears into vapor, the liquid grows thicker, darker, and far more concentrated. What once flowed like ordinary juice slowly transforms into a dense golden syrup loaded with dissolved sucrose. The texture becomes heavy and glossy. Steam rises from the surface. Industrial mixers rotate slowly to keep the syrup stable under intense heat. This concentrated material is known as mother liquor, and it represents one of the most important transition points in the entire factory, because now, for the first time, the process is finally approaching the form people recognize as sugar. But creating perfect sugar crystals is far more complicated than simply boiling syrup. At this stage, even small changes can create major problems. A slight temperature shift can damage crystal formation. Improper concentration can affect texture. Poor timing can reduce product quality across huge production batches, and conditions inside the evaporation area continue becoming more extreme. The heat intensifies near the steam systems. Giant pipelines carrying superheated vapor shake under pressure, while pumps force syrup between chambers beneath flashing monitoring screens and automated control systems. Yet despite all this machinery, the final transformation still has not happened. Not yet. Because the most delicate and visually satisfying stage of the entire operation is about to begin. Crystallization. This is where boiling golden syrup will slowly transform into billions of sparkling sugar crystals through one of the most carefully controlled industrial processes inside the factory. Inside the crystallization section, the entire atmosphere changes again. The violent grinding systems and roaring extraction mills are gone. In their place comes something slower, more controlled, and far more delicate. After all the crushing, heating, filtering, and evaporation, the entire operation now depends on how perfectly sugar crystals can form inside giant industrial chambers. Damn. And even small mistakes at this stage can damage huge production batches. The thick golden syrup arriving from the evaporators is pumped into enormous sealed vessels known as vacuum crystallizers. These machines tower above the factory floor, surrounded by steel walkways, monitoring systems, valves, and dense networks of pipes feeding heat and circulation systems into the chambers. Inside them, operators create carefully controlled conditions where crystals can grow without overheating the syrup. The pressure inside the vessels is reduced using vacuum systems, allowing the liquid to boil at lower temperatures. This gives technicians far greater control over crystal formation while protecting the sugar from burning too early. Then comes one of the most important moments in the entire factory. seeding. Tiny sugar crystals are introduced into the syrup to act as starting points for crystal growth. These microscopic particles become the foundation upon which dissolved sucrose slowly begins attaching itself layer by layer. At first, almost nothing seems to change. But inside the chambers, billions of crystals are quietly forming at the same time. The syrup circulates slowly through the vessel. The temperature shifts with extreme care. Concentration levels are monitored constantly from nearby control systems. And over time, the crystals begin growing larger inside the dense golden liquid. This stage is incredibly sensitive. If the syrup cools too quickly, crystals can grow unevenly. If agitation becomes too aggressive, the grains can fracture. If concentration levels drift too far, texture and quality begin breaking down across the batch. So operators continuously monitor the process using sensors, digital control systems, and visual inspections while adjusting heat and circulation with remarkable precision. Inside the crystallization area, the environment feels strangely hypnotic compared to the violence of the crushing line earlier in the factory. Heavy mixers rotate slowly through thick syrup. Large viewing ports reveal dense, crystal-filled liquid moving inside the chambers. Control panels glow beneath dim industrial lighting, while technicians track changes occurring deep inside the vessels. And eventually, the transformation becomes visible. The once smooth golden syrup slowly turns into a dense mixture packed with sparkling sugar crystals suspended inside dark molasses. Under factory lights, the surface begins reflecting light like wet snow mixed with caramel-colored liquid. For the first time, the material truly begins looking like sugar, but the crystals are still trapped inside heavy syrup. And separating them requires another massive machine, the centrifuge. This is one of the fastest and most visually intense stages inside the entire factory. Giant industrial centrifuges spin at extremely high speed, while loaded with crystal-filled syrup. The force generated inside these machines is powerful enough to separate molasses from solid sugar within minutes. As the drums accelerate, dark syrup blasts outward toward the walls of the spinning chamber while cleaner sugar crystals remain concentrated closer to the center. The speed is incredible. Rows of centrifuges vibrate across the floor while operators monitor balance, rotation speed, and discharge flow carefully because even small irregularities at these speeds can place enormous stress on the machinery. Slowly, the crystals emerge, cleaner, brighter, and more refined. At this stage, factories can already influence the final type of sugar being produced. If manufacturers want brown sugar, part of the molasses coating is intentionally left attached to the crystals, giving them their darker appearance and deeper flavor. But for white sugar, additional cleaning stages are necessary. Hot water or steam washes through the spinning crystals to remove remaining molasses. Before the sugar advances deeper into the refining line, the transformation is dramatic. Dark syrup-covered crystals suddenly become pale, dry, and bright beneath the industrial lighting. Yet even now, the sugar still contains moisture. Moisture creates serious storage problems. If the product remains too wet, clumping and spoilage can occur during transportation and packaging. So the crystals move into large drying systems where heated air flows through rotating chambers and drying tunnels designed to remove remaining moisture without damaging the sugar itself. This is where the product finally takes on the texture people instantly recognize. As warm air passes through the crystals, cooling systems prevent overheating while conveyors transport endless streams of sugar beneath bright lighting across the final conditioning stages. The sound inside these areas feels completely different from the earlier factory sections. Less violent, more rhythmic, almost mechanical in a strangely calming way. Conveyors glide steadily beneath the lights, while thousands of tiny crystals shimmer across moving belts like flowing white sand. Then comes sorting. Not all sugar crystals are the same size, and different industries require different textures depending on how the sugar will eventually be used. Some products require ultrafine sugar for baking and confectionery applications, while others demand larger granules for industrial food manufacturing. So the crystals pass through vibrating screening systems that separate them according to size with remarkable accuracy. Fine sugar falls through smaller openings, larger crystals continue forward, Oversized material gets redirected back into processing systems. Every stage is optimized for consistency. And in the most advanced refineries, the purification process can continue even further. Some sugar is dissolved again, filtered through activated carbon systems to remove final traces of color, and crystallized once more before emerging as highly refined white sugar with exceptional purity. By this point, the transformation is almost unbelievable. Only hours earlier, this material was dark raw juice extracted from shredded tropical plants. Now it has become clean, dry sugar crystals ready to move into homes, bakeries, restaurants, food factories, and supermarkets around the world. But while the sugar itself is nearly finished, another side of the factory is still operating at full intensity, because the leftover material from this process is about to begin an entirely different transformation. Even after the sugar leaves the crystallization systems, the factory is still far from finished. Because modern sugar production is no longer just about producing sweet crystals. It has evolved into a massive industrial ecosystem where almost every leftover material is transformed into something useful. And in some facilities, the systems handling byproducts have become just as important as the systems producing sugar itself. Deep inside another section of the plant, conveyor belts continue carrying large volumes of bogas away from the crushing mills. Earlier, these dry cane fibers helped fuel giant boilers and steam turbines powering the factory. But energy production is only part of what happens next. Some facilities now process bogas into industrial materials designed to replace single-use plastics. Mechanical systems wash, shred, compress, and refine the fibers into thick pulp before feeding the material into heated molding equipment operating under intense pressure. Inside these machines, the pulp is transformed into biodegradable trays, food containers, plates, cups, and packaging products strong enough for commercial use. The transformation is remarkable. What started as leftover plant fiber only hours earlier now emerges as finished industrial products stacked beside automated packaging lines ready for shipment. And unlike plastic, many of these materials can naturally decompose within months under proper conditions. Meanwhile, elsewhere inside the factory, molasses separated during crystallization continues moving through an entirely different production chain. This dark, heavy syrup still contains valuable organic compounds and residual sugars, making it useful far beyond food manufacturing. Some facilities process molasses into animal feed additives. Others use it in fermentation systems for ethanol production and other bio-based industrial products. Even the sludge removed earlier during clarification returns to the fields as fertilizer, carrying nutrients and organic matter back into the soil, where future sugarcane crops will eventually grow again. Slowly, the entire operation begins revealing itself as a giant industrial cycle. Fields supply the factories. Factories generate energy. Byproducts return to agriculture. And the process repeats harvest after harvest at enormous scale. But eventually the sugar itself reaches its final stage, packaging, compared to the crushing mills and turbine halls. Earlier in the factory, this section feels cleaner, brighter, and far more controlled. Refined sugar moves through enclosed packaging systems designed to protect the product from moisture and contamination before shipment. Above the conveyors, automated sensors monitor the sugar continuously while weigh,